the cosmic heart. Deep in the constellation Cassiopeia lies one of the universe's most romantic formations, the Heart Nebula, officially designated IC 1805. This striking emission nebula earns its name honestly, glowing with an unmistakable heart-like shape that seems almost too perfect to be coincidence. The Heart Nebula is a vast stellar nursery, spanning roughly 150 light-years across space. To put that in perspective, if you could see it clearly from Earth, it would appear about 2 degrees wide in the night sky. That's equivalent to 4 full moons placed side by side. The nebula covers an impressive 150 by 150 arcminutes, making it a substantial presence in our cosmic neighborhood. What gives this celestial heart its distinctive glow? Ionized hydrogen gas. When young, hot stars blast the surrounding hydrogen with intense ultraviolet radiation. They strip electrons from the atoms, causing them to emit that characteristic reddish light. The nebula's heart shape is further defined by 2 dark voids, like chambers of a cosmic heart, creating the silhouette we recognize. While the Heart Nebula itself is relatively faint, with a surface brightness hovering around magnitude 7, there's a brilliant star cluster embedded within it that shines considerably brighter at magnitude 6.2, serving as the engine that powers this cosmic Valentine. Where it lies. The Heart Nebula makes its home in the constellation Cassiopeia, that distinctive W-shaped pattern easily recognizable in northern skies. Located near the Perseus Arm of the Milky Way, this cosmic heart beats at a distance of approximately 7,500 light-years from Earth. For those who navigate the night sky with precision, you'll find it at coordinates right ascension 2 hours 33 minutes 24 seconds and declination plus 61 degrees 30 minutes 36 seconds. But the heart doesn't beat alone. It's paired with a companion nebula, IC 1848, known as the Soul Nebula. Together, these 2 formations create what astronomers call the Heart and Soul Complex, a poetic coupling of stellar nurseries that seem destined to be forever linked in the cosmos. The Heart Nebula is part of an even larger story. It belongs to the extensive W3, W4, W5 star-forming complex, a sprawling region of stellar birth and evolution. In fact, the heart forms the brightest portion of what's known as the W4 superbubble, sometimes called the W4 chimney. This massive structure acts as a cosmic ventilation system, channeling superheated gas from the galactic disk upward into the halo, a testament to the violent and energetic processes constantly reshaping our galaxy. The power source at its core. Every heart needs something to make it beat, and for the Heart Nebula, that power comes from Melat 15, also known as Colander 26, a young open star cluster burning brilliantly at the nebula's center. This stellar cluster is extraordinarily young by cosmic standards, a mere 1.5 million years old. That might sound ancient, but in astronomical terms, these stars are newborns. The cluster contains massive O-type and B-type blue stars, stellar giants that dwarf our own Sunday. Some of these behemoths tip the scales at up to 50 times the Sun's mass, burning with an intensity that's almost incomprehensible. Collectively, the cluster produces roughly 100,000 times the luminosity of our Sun. This tremendous energy output doesn't just shine into space, it actively sculpts the nebula itself. The intense radiation and powerful stellar winds from these massive stars slam into the surrounding hydrogen gas, stripping away electrons and ionizing the atoms. This process creates the nebula's vivid red glow that defines its heart-shaped appearance. But the Heart Nebula's color palette doesn't stop at red. The nebula also glows with ionized oxygen and sulfur, which reveal themselves as blue and orange hues in narrowband imaging techniques. When astronomers examine diagnostic line ratios, measurements like nitrogen 2 to hydrogen alpha and sulfur 2 to hydrogen alpha, they find evidence of something more complex than simple photoionization. These signatures reveal stellar wind shocks, violent disturbances where supersonic winds from the massive stars crash into the surrounding gas, adding another layer to this nebula's dynamic and energetic nature. A stellar nursery. The Heart Nebula isn't just a beautiful remnant of past stellar activity, it's an active stellar nursery where new stars are being born right now. Within the nebula's dusty pillars, Protostars are forming in dense cores, slowly gathering mass and igniting the nuclear fires that will sustain them for millions or billions of years to come. Deep imaging surveys have revealed the true extent of this stellar maternity ward. Astronomers have identified 384 young stellar objects, or YSOs, scattered throughout the Heart Nebula. These include 101 Class 1 and Class 2 objects, stars still deeply embedded in their natal cocoons of gas and dust, along with 283 Class 3 objects, which are more evolved and have largely cleared away their surrounding material. This census extends down to stars as small as just 0.2 of a solar mass, capturing the full range of stellar birth. When astronomers analyze the distribution of these stellar masses, they find something remarkable. The mass function follows what's called a salpeter-like slope, with a value of -1.23 plus or -0.23. This tells us that star formation in the Heart Nebula follows the same fundamental patterns we see throughout the galaxy: nature's preference for creating many small stars and only a few massive ones. The low-mass young stellar objects average about 2.5 million years in age, with typical masses ranging between 0.3 and 2.5 times the mass of our Sun. Studies of their radial density distribution reveal a concentrated core radius of roughly 9 arcminutes, which translates to about 5 parsecs in actual space. What's particularly fascinating is how these young stars are distributed. They're not scattered randomly. Instead, they align along filaments of gas and dust, painting a picture of formation within a large filamentary molecular cloud. These cosmic threads act as highways for star formation, channeling material into dense knots where gravity can take over and build new stars. Perhaps most surprising is what the massive stars at the center aren't doing. Despite their intense radiation and powerful winds, these stellar giants appear to have little destructive impact on the circumstellar disks surrounding nearby young stars. Disk fractions remain stable, suggesting that even in this energetic environment, planetary systems can form and survive around newborn stars. Shaped by violence. The Heart Nebula's beautiful appearance belies a violent past. This region has been sculpted not just by gentle stellar winds, but by catastrophic events that have fundamentally reshaped the cosmic landscape. Some studies suggest that a supernova exploded somewhere between 10,000 and 20,000 years ago, sending a shockwave rippling through the surrounding molecular cloud. This cataclysmic death of a massive star may have been the very trigger that caused parts of the cloud to collapse, initiating the wave of star formation we observe today. In this way, stellar death became the seed of stellar birth. The region's turbulent history doesn't end there. Evidence suggests that the Heart Nebula once hosted a microquasar, an exotic binary system where a stellar mass black hole or neutron star devours material from a companion star, launching powerful jets at near light speed. But this microquasar no longer calls the Heart home. Violent gravitational interactions within the dense star cluster eventually ejected it, flinging it out into space like a stone from a slingshot. When astronomers trace the nebula's expansion, they calculate a dynamical age of approximately 14 million years. This extended timescale reveals that the Heart hasn't been shaped by a single generation of stars, but by sequential clusters forming, living, and dying over millions of years, each leaving its mark on the surrounding gas. Detailed spectroscopic measurements reveal the physical conditions within the nebula itself. Mean electron densities hover around 180 particles per cubic centimeter in the singly ionized sulfur zone, a fairly dense environment by interstellar standards. The ratio of nitrogen-2 emission lines at wavelengths 6,548 and 6,584 angstroms slightly exceeds a value of 3, a subtle but telling signature. This deviation results from collisional de-excitation occurring at densities between 80 and 310 particles per cubic centimeter, providing astronomers with a precise diagnostic of the physical conditions where these photons originated. In visible light, the Heart Nebula reveals different secrets depending on how we choose to observe it. While optical telescopes capture the stunning red glow of ionized hydrogen, there's an entire invisible spectrum telling complementary stories about this cosmic structure. At radio wavelengths, particularly at 21 centimeters, the Heart Nebula emits strongly, tracing neutral hydrogen gas that hasn't yet been ionized by the cluster's intense radiation. This emission maps the Perseus Arm of our galaxy, revealing the large-scale distribution of material from which stars form. It's like seeing the raw material that hasn't yet been processed by stellar fire. The nebula's presence in radio surveys goes back decades. In 1958, Dutch astronomer Gart Westerhout was cataloging radio sources across the sky when he identified this region. He designated it Westerhout 4, or simply W4, a name still used by astronomers today, particularly when discussing the larger star-forming complex of which the Heart is a part. Modern observatories have pushed our understanding even further. The SBIOMM instrument, the Spectrophotometer Imageur de l'Observatoire du Mont Mégantic, has mapped the nebula's emission lines in exquisite detail. These observations capture hydrogen alpha, nitrogen 2, and sulfur 2 emissions, creating detailed maps that reveal the nebula's temperature, density, and ionization structure. Each emission line acts like a probe, sampling different physical conditions within the gas and painting a complete picture of the Heart's complex anatomy. Human discovery. The Heart Nebula's story intertwines with the history of astronomy itself, stretching back over 2 centuries to the dawn of deep sky observation. The first human to glimpse part of this cosmic heart was the legendary William Herschel. In 1787, using his handcrafted reflecting telescope, Herschel observed a portion of the nebula and catalogued it as NGC 896. At the time, Herschel couldn't have known the full extent of what he was seeing. His telescope revealed only a fragment of the larger structure, a single piece of the heart-shaped puzzle. Nearly 8 decades later, in 1864, the 3rd Earl of Rosse turned his attention to this same region of sky. Using the massive Leviathan of Parsonstown, the 72-inch reflecting telescope at Bear Castle in Ireland, then the largest telescope in the world, Lord Rosse observed the nebula, adding his own notes to the growing astronomical record. As catalogues expanded and observations accumulated, the nebula received additional designations. It became known as IC 1805 in the Index Catalog, a supplement to the new General Catalog that documented thousands of nebulae, star clusters, and galaxies. Later still, it earned the designation Sharpless 2 to 190 or 2 to 190 shillings, when American astronomer Stuart Sharpless compiled his comprehensive catalog of H2 regions in the 1950s. Each name represents a chapter in our growing understanding, from Herschel's first glimpse through an 18th-century eyepiece to modern comprehensive surveys that reveal the Heart Nebula in wavelengths our eyes could never see. Seeing the Heart. For those who wish to observe the Heart Nebula themselves, timing and technique are everything. The Heart is best observed from October through April in the Northern Hemisphere, when the constellation Cassiopeia rides high in the night sky. From northern locations, peak visibility comes during late autumn evenings, when the constellation reaches its highest point and atmospheric interference is minimized. For visual observers peering through telescopes, the Heart Nebula presents a challenge. Its low surface brightness means that even under dark skies, only the brightest regions reveal themselves to the eye. The embedded star cluster shines more readily, but the nebula's delicate heart shape remains elusive to all but the most experienced observers with the largest amateur telescopes. It's in the realm of astrophotography that the Heart Nebula truly reveals its glory. The nebula has become a beloved target among astrophotographers, who employ specialized narrowband and dual-band filters to isolate specific wavelengths of light. These filters cut through light pollution and enhance contrast, separating the nebula's glow from the background sky. Hydrogen alpha imaging, targeting the emission at 656 nanometers, has become the gold standard for capturing the Heart's intricate structure. But patience is required. Revealing the nebula's faintest tendrils and subtle details often demands 20 hours or more of total exposure time, accumulated over multiple nights. Photographers carefully stack dozens or even hundreds of individual frames, teasing out signal from noise until the Heart Nebula's full beauty emerges, a testament to both cosmic grandeur and human dedication. The bigger neighborhood. The Heart Nebula doesn't exist in isolation. It's part of a rich and crowded stellar neighborhood teeming with astronomical treasures. The broader region hosts no fewer than 7 open star clusters, including Basel 10 and GC 957 and Berkeley 65. These clusters are all members of the Cassiopeia OB6 Association, a loose grouping of hot, massive O-type and B-type stars that share a common origin and motion through space. Together, they paint a picture of large-scale star formation that has been ongoing for millions of years across this entire region of the Perseus Arm. Nearby, we find additional nebulae that complete this cosmic tapestry. The Fish Head Nebula, catalogued as IC 1795, lies in close proximity, along with IC 1871. Each of these glowing clouds represents its own stellar nursery, its own generation of stars being born from collapsing molecular gas. They're siblings to the Heart, formed from the same giant molecular cloud complex that has been fragmenting and forming stars for tens of millions of years. But perhaps the most intriguing neighbors lie just a few degrees away, Maffei 1 and Maffei 2. These are not nebulae or star clusters, but entire galaxies, hidden from easy view behind the thick veil of Milky Way dust. Discovered only in 1968 by Italian astronomer Paolo Maffei using infrared techniques, these galaxies remain among the most obscured major galaxies in our local universe. They're so close, cosmically speaking, yet rendered nearly invisible by the accident of lying along our line of sight through the dustiest part of our own galaxy's disk. It's a reminder that even in our own cosmic backyard, mysteries remain hidden, waiting to be unveiled. The future of the Heart. Like all things in the cosmos, the Heart Nebula is not eternal. Its fate is already written in the life cycles of the massive stars that bring it to life. As an H2 region, a cloud of ionized hydrogen gas, the Heart's existence is intimately tied to the young, massive stars at its core. These stellar giants burn through their nuclear fuel at a prodigious rate, living fast and dying young. In just a few million years, a cosmic heartbeat, these stars will reach the end of their brief lives and explode as supernovae. When they do, the shock waves will tear through the nebula, shredding its delicate structures and dispersing its gas back into the interstellar medium. The Heart Nebula will fade. Its distinctive shape will blur and vanish. The glowing hydrogen will cool and darken. What remains will be an expanding shell of enriched gas, seeded with heavy elements forged in the cores of dying stars, carbon, oxygen, iron, and all the building blocks of future planets and life. Yet even as the Heart fades from view, its legacy will endure. Though its apparent magnitude makes it appear faint from our vantage point on Earth, its intrinsic brightness is truly significant. The Heart Nebula shines with the power of thousands of suns, a beacon visible across thousands of light years. And when its gas disperses, it won't simply vanish. It will become the raw material for the next generation of stars, perhaps forming new stellar nurseries, new planetary systems, new worlds. In this way, the Heart Nebula reminds us that in the universe, endings and beginnings are one and the same. Death feeds rebirth, and the cosmic heart beats on.